All right, so now what we're going to be learning about is how to translate from a word equation into a balanced chemical reaction. So the first thing that you're going to have to know is understand that certain elements actually don't exist by themselves. They always exist as a diatomic molecule. Let's break this down. What does di mean? Well, it's two, and then atomic is atoms to make up a molecule, so something that's bonded, right? Okay, and so what happens is whenever these 7 elements are by themselves, they actually exist as 2 of them. They have 2 of them, not 1. So what are those 7 elements? They're called Hunkelbriefs. Other teachers call them Hoberfinkels. Basically what it is that it is these 7 elements, H, O, N, C, L, B, R, I, and F. And when they are by themselves in their elemental state, you actually have them as diatomic, meaning H2. So there is no H by itself. Okay, there's no elemental H of hydrogen. It always exists as H2. Same with oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. When you look at the elements, it actually is, we also call them the 7 up elements. And what does that mean? Well, you start at the number 7, you form the number 7 and up. So it's the 7 up elements. Those are the 7 elements that always exist as diatomic molecules. Now, if I say the word sodium or the element sodium, sodium is not one of those 7, so it would exist as Na, not Na2. All right, so what are the hints for chemical reactions? First, I recommend, especially initially, is box out your compounds and underline your elements. You can underline or box. It's just so that you remember that I have to treat them differently. Okay, if you see the words and or with, it typically means a plus sign. Yields, forms, produces, that shows an arrow, so it's like reactants separating from products. And for the elements, whenever you have an element, so one things I underline, you have to worry about your Hunkelbriefs. So let's try to worry about this. So sodium hydroxide plus magnesium sulfate goes to magnesium hydroxide and sodium sulfate. So I'm going to box out all my compounds. So we got sodium hydroxide, that's a compound, magnesium sulfate compound, magnesium hydroxide compound, and sodium sulfate compound. So what do you have to worry about with compounds? Typically in this class, you're going to either have covalent or ionic, and 95% of the time it's going to be ionic because those are the things that we readily use in this class. So when you have an ionic compound, remember you have to worry about your charges and crisscrossing your charges. Crisscross. All right, so sodium hydroxide is its own compound, so I'm going to worry about my charges. Na is charges plus 1. Hydroxide is a polyatomic, so it's OH minus 1. I crisscross and I get NaOH. Then I'm going to do a plus. Magnesium sulfate is Mg with a plus 2. Sulfate is polyatomic ion with a minus 2. You crisscross because they reduce, you get MgSO4. Arrow means yields, so these are my reactants on the left-hand side. Now I'm ready to start my products. I've already come up with the charges on the other side, so I could literally just copy them from the other side, and we get all of these that we are going to then have to crisscross. So we end up with Mg parentheses OH parentheses 2 plus Na2SO4. All right. Now the last step is that you have to balance these. Balancing, you might be able to do this in your head right now. I've got 2 OHs on my right, or my product side. I have 1 on my left, so I'm going to put a 2 as my coefficient here. I now have 2 NAs. I have 2 NAs on the right. I have 1 Mg on the left. I have 1 Mg on the right, and I have 1 SO4 on the left, and I have 1 SO4 on the right. So this is my final balanced reaction. All right, next one. Hydrogen reacts with oxygen to form water. So underline my elements. Hydrogen is by itself. It doesn't say hydrogen peroxide or something else, so I'm going to leave it as an element. Reacts with, I see that word with, and it also tells me that it's reacting, so I know that these are going to be the reactants. Oxygen, so that's another element. To form, so to form means that we're producing it. And then we've got water. Water is a compound that I do expect you to have the formula memorized. So with all elements, when I'm trying to do hydrogen and oxygen, I need to worry about my Hunkelbriefs. Are they Hunkelbriefs or not? Hydrogen is H, so yes, it is a Hunkelbrief. So the only thing you ever have to worry about with elements is it a Hunkelbrief or not. If it is a Hunkelbrief, you put a 2. If it's not, you just leave it. So hydrogen, I need to put a 2 because it is a Hunkelbrief. Plus oxygen. Is oxygen a Hunkelbrief? Yes, it is. So I'm going to put a 2. And then arrow to form water. So I've got H2O. All right, to try to balance this a little bit harder, my hydrogen's already balanced, so now I have to do my last one, which is oxygen. So I'm going to put a 2 in front of that oxygen to balance them both out. And then now I need to put a 2 in front of that hydrogen to balance that out. And that is my balanced reaction. right, hopefully you kind of have a basic understanding to just remember when you have an element, you're going to worry about those Hunkelbriefs or those diatomic molecules that you do absolutely have to have them memorized. You never have to worry about charges with elements. Literally the only thing you have to worry about is it a Hunkelbrief or not. The second one is with compounds. You typically are going to have to worry about charges and crisscrossing those charges because we typically deal with ionic compounds. If it is not an ionic compound, it'll probably be a covalent compound, and therefore you just have to worry about those subscripts and stuff like that. All right, have a great evening, and hopefully you kind of have a basic understanding, which we'll practice more tomorrow.